So in this video, we're going to be checking our assumptions in our descriptives and our plots. So here's a summary of what we're going to be checking for. And then by each plot, our histogram, we're going to check for normality and our outliers. In our scatter plot and our box plots, we can pretty much check for a lot of different things. Not necessarily normality, but our outliers, and then we can look for linearity, independence, and equal variance. Similar for our box plots. You can actually kind of tell if there's a nonlinear relationship in box plots, but it's not quite as easy. All right, so in our steps for data analysis, we think about our file names. Here we're using the secondary data in Stata and SPSS over here. What variables are we including? Our research question is going to be, how are gender and school belonging associated with interest in school? So our variables are gender, school belonging, and interest. How are they measured? Gender is measured, let's go over here, on a 0 to 1 scale. 0 is girls, 1 is boys. Interest is on a 1 to 5 scale, and belonging is on a 1 to 5 scale. And how we indicate missing variables are blanks. Okay, what file formats are we using? We're using our SPSS.sav files and our Stata DTA files. Our dependent variable. Since our research question is how are gender and school belonging associated with interest in school, interest here is our dependent variable. Our independent variables are gender and school belonging. We have no controls, moderators, or mediators. And our hypothesis is that girls will be more interested in school and belonging will have a positive interest in school. All right, so what is the level of measurement for each variable in our analysis? For gender, that's going to be a categorical variable. Belonging and interest are going to be continuous variables. And then we want to check if our data meets the requirement. So to check that, we're going to look in Stata, you can look at the data editor. In SPSS, you want to look at the data view. So each case has one row of data with at least 2 variables. These are cases here in each row. Each regression model has one dependent variable, and that is going to be interest. The dependent variable is continuous. Interest is continuous here. And each variable is represented in one column of numbers. We can check that. There's gender, there's interest, and there's belonging. So we are good to go. On to step 5, running our descriptive statistics and our plots. So here's the Stata code and the SPSS code that I've just copied into a do file. So let's start with Stata. So here's that same code you can see over here that I've copied over. And you're going to be basically replacing the words variable and dependent and independent with your variable names. So first, we're going to use summarize on our continuous variables, belonging and interest. For our categorical variables, we'll do tab. So let's see what Stata is showing us over here. So there's our continuous variables and there's our categorical variables. So what are we looking for? Are the means and standard deviations what you might expect? Are any values out of range? And does anything look weird? All right, so our mean for belonging is 3.68. So that's right, a little bit slightly higher than the middle of a scale. So that's pretty good. Standard deviation 0.76, that seems fine. We would probably be worried if we had a standard deviation that was greater than 5. Otherwise you might expect school belonging to be really variable. In this case, not so much variable. So that's fine. Our variance and skewness are indicating that we are not too far off from where we want to be. So remember in Stata, we're looking for skewness values of 0. So our skewness is just negative 0.45. And we're looking for those kurtosis values of 3. And so here we're just under 3 for belonging. So that's good. For interest in school, again, our mean is around 3, our standard deviation is a little bit larger. Skewness, again, is even better, and kurtosis is a little bit worse, but that's okay. still not extreme. And for gender here, we're not really looking for a lot since there's only 2 categories. And in this data set, we would know from the way that the data was collected that we were trying to get about even split in gender. And so you can see that here, 55% girls, 45% boys. So that is what we would expect. So nothing looks weird so far. So we are ready to run our histograms and look a little bit deeper into this normality assumption. So start with belonging. Here is our histogram. All right, so how skewed or skinny or flat do the distributions look? So we already saw that we had a little bit of issue with kurtosis, so you can see that over here. Most kids are really feeling positive about their school belonging. That's actually a good thing. That's what we would kind of want to see kids having, feeling like they belong at school. So that is good. And it's a little bit flat, as you can see, because we got some spread out folks down at the very bottom. But in general, this looks good. Do we see any outliers? So this scale, again, is from 1 to 5. And so these folks are here a little bit, off of the mean, the major people in the group, but they're not outliers because they're pretty still close to most everyone. So that histogram looks good. Let's take a look at interest. So here's interest. So you can see, and in Stata and SPSS, you can actually change these boxes here. So you can change how close everything is grouped. But in general, we can take a look at this and see, not quite as normal as belonging was. No outliers within our range of 1 to 5. So we're doing pretty good on this one as well. Okay, so now we can move on to our scatter plot. So when we could do a histogram for gender, it's not going to be terribly interesting, but that's what it looked like. See, there's our girls, there's our boys. So in general, unless you have a lot of categories in a categorical variable, you're not going to do a histogram for a categorical variable. Okay, on to our scatter plot. So we're looking for initial support for our hypothesis. So if you remember, our hypothesis was that belonging would have a positive relationship with interest. What we're seeing here, get everything organized like I want. What we're seeing here is that with our fit line, we can see that higher scores on belonging are associated with higher scores on interest in school. So you can see this on the fit line. You can kind of see the trend of the dots also going upward. So there's initial support for our hypothesis. Are there any outliers? Everyone's pretty much grouped pretty well together, so there's not any outliers in this data. Do the dots on the scatter platform align more or less, or do they look curved? Now, with the way this data is grouped, you can kind of see that a lot of people reported high interest in school, so we kind of have a ceiling effect going on here. But in general, this data is pretty linear. What we're not seeing is a curve, so that would really be evidence against the linearity assumption if we saw a distinct curve. But here we just kind of have this clump of clump of people, and you can draw a line through that. That's fine. Independence. Is there any evidence of correlated observations? We don't see any patterns here that would indicate that some of the observations are correlated. And it doesn't necessarily seem to be the case that our independent variable, we can't tell if our independent variables are highly correlated from this scatter plot. And then for the equal variance assumption, our values evenly spread out across the range. Now this one is where we kind of get a little tricky, because when you see over here, they're kind of spread out, but it's mainly because these folks over, we have 2 people who have a 5 on interest and a 1.5 on school belonging. So in general, there's definitely some even spread over on this side. Over here, it's a little bit questionable, but not enough for us to be concerned about this data. Now, if we didn't want to check out this independence assumption, what we would look at is our two independent variables together. So let's actually run our first box plot with belonging and gender. So this is a test whether we have multicollinearity with our two independent variables. All right, so what we'd be looking for is that gender would be strongly associated with school belonging. You can see here girls and boys pretty much have a similar level of school belonging, so we're not concerned about multicollinearity or lack of independence with our independent variables here. So that's answering this question right here. All right, then our last box plot is going to be looking at interest and gender. So this is testing our hypothesis again. All right, so now we're up here looking for initial support for our hypothesis. If you remember, our hypothesis that would be that girls would be more interested in school. And you can see this is the mean line, that girls are actually slightly less interested in school than boys are. So we don't have support for our hypothesis with this box plot. We have a couple of outliers for the boys over here, but they're not extreme. They're still within the girl range, actually, so it's not a big concern. We're not going to look for linearity in our box plots, but we can look at if there's any evidence of correlated observations. We can't really check that in a box plot either. There's nothing here that would indicate that. And then for our equal variance assumption, we want to check if the values are evenly spread across the range for both groups. So you can kind of see here that boys and girls have a very similar range of scores for interest in school. So that's a good thing. That's what we want to see. All right, so now let's go over to SPSS and I'll show you how to check these same things. So here's our SPSS file and our syntax with everything in it. So here's that syntax that's been copied from the steps in data analysis handout. And then first we're going to run our frequencies and get a histogram for everything. Now, like I said, you don't necessarily need a histogram for gender, but since SPSS allows you to run multiple variables in one command, I'm just going to go ahead and put it in there so I can get those frequencies. All right, so here's what it looks like in SPSS. We first get our mean, standard deviation, skewness, and kurtosis. And remember with SPSS, we're looking for kurtosis values of 0. So again, we're seeing here interest being a little bit more kurtotic than belonging. But we're getting the same means and standard deviations. Here's our histogram for gender. There's school belonging, so you can see the same thing, even though SPSS graphs look slightly different, and interest in school. And now we want to use our chart builder to get these other plots. So first we're going to get a scatter plot of belonging and interest. So we go to graphs, chart builder. So we want to view our scatter plot with a fit line. We are going to right click to display our variable names, just to make it a little bit easier. Interest is our dependent variable, so it is going to go on the y-axis, and belonging is our independent variable. It goes on the x-axis. We click OK. You can also click paste if you want to save this for later. The chart builder syntax is a little intense looking, but if you want to save it for later and not have to click through the menus, then you can do that. So there's that scatter plot. So you can see it looks very similar to what we saw in Stata. There's our fit line. We're seeing support for our hypothesis. We're seeing everyone kind of grouped up over in this top corner over here. If you wanted to run that plot, those box plots, like so, then we're going to reset this. And now we're interested in our box plot of gender versus interest. So box plot is right here in SPSS. Interest is on the y-axis, and gender is on the x-axis. Now here's the problem. SPSS is not letting me put this in here. This is a special situation that's unique to SPSS and the chart builder. The chart builder likes you to have your variables arranged by type very specifically. So you can see this ruler here. This indicates that these are all continuous variables, which SPSS is like, okay, you can't put a continuous variable in the box plot. But SPSS is wrong. It's not a continuous variable. Gender is a categorical variable. So what we need to do to get SPSS to realize that is to just right click or command click and change this to nominal. So now you can see it has, so you would want to do this for all of your variables, but sometimes it's just a case by case basis if you don't want to go ahead and do it beforehand. But I just changed this to gender, and now you can see it finds the categories automatically for me. And now when I slide this over, it lets me put it in there. What's your gender? I click OK, and there's our box plot. So the nice thing about SPSS is that it actually shows you the case number of your outliers over there. So we could go to the data view and see there's actually 3 boys who have this particular value of interest in school here, and see those values in the data. And then we'd be able to look at the case for their other variables and see, oh, are they special in some other ways? Are these people that maybe we should be thinking about eliminating from the data? All right, so that's how you run your descriptives and check for your assumptions in SPSS and Stata.